welcome to Crashing Online Classes. In your previous class, you have studied about the effects of electric current. When the electricity flows through the conductor. What is a conductor? Any material or any substance through which electric current flows. We call them as conductor. So, when electricity flows through any conductor, we can see three effects of electric current. Which are the three effects of electric current we have studied? The first effect is heating effect of electric current. Heating effect. Heating effect of electricity or heating effect of electric current. Second effect is magnetic effect. Magnetic effect of electric current. And the third effect is chemical effect of electric current. Chemical effect of electric current. When electricity flows through any conductor, three effects are possible. They are heating effect, magnetic effect, and third one is chemical effect. So what is heating effect of electric current? Heating effect of electric current in the sense when electricity flows through a conductor. When electricity flows through a wire, a conducting wire, when the electricity flows through a conductor or a wire, a part of electrical energy converted into heat energy. A small amount of electricity gets converted into heat energy. We get heat energy from the electricity. Using electricity, we get heat energy. So this effect we call as heating effect of electric current. Now go to the third effect, second effect, that is magnetic effect of electric current. So what is this magnetic effect of electric current? When electricity flows through a conductor or a wire, when electricity flows through a wire, consider this is a wire through which electricity flows. Then what happens? Around the wire, magnetism is produced. Around the wire, it produces magnetism. Magnetic field is created around the wire. So this effect we call as magnetic effect of electric current. And the third effect is chemical effect of electricity or chemical effect of electric current. So what does it mean? So this effect mainly takes place when electric current flows through some conducting solutions. Conducting solutions. Conducting solutions. So which are the conducting solutions? Most of the solutions which conduct electricity are the solutions of acids and bases. About this we have conducted activities and we have tested the conduction of electricity by taking some acids as well as some bases. So the liquids or the solutions which allow electricity to flow through them, they are the solutions of acids as well as bases. So when electricity flows through such type of solution, such a type of conducting solution or such a type of liquids, we can see some of the chemical changes. Chemical changes takes place or chemical reactions takes place. Chemical changes or chemical reactions takes place. Due to this chemical changes, chemical reactions takes place. So this effect we call as chemical effect of electric current. When electricity flows through some of the liquids or some of the conducting solutions, we can see the changes, chemical changes in the solution. Chemical changes takes place. Chemical reactions takes place. This we call as chemical effect of electric current. So what type of chemical change we can see here? Which type of changes are possible during a chemical reaction? So during a chemical reaction or during the chemical effect of electric current, the changes takes place mainly are we can see the formation of gas bubbles. Bubbles of gases are formed. Gas bubbles. Bubbles of gases are formed on the electrode. change in the color. Change in the color of the solution takes place, or there may a metal deposition of metal gets deposited on electrode. So as I said, during chemical changes or during chemical effect of electric current, electricity flows through the conducting solution. So when electricity flows through conducting solution, when we make electricity flows through the solution, chemical changes takes place during the chemical effect of electric current. So what are the chemical changes takes place? So chemical changes takes place. There may be gas bubbles formed on the electrode. Gas bubbles formed on the electrode. So what is this electrode? Electrode, there are two types of electrodes, cathode as well as anode. For example, if you take a conducting solution in a beaker, as I said, we have to pass the electricity. So how we can make electricity flows through the solution? By connecting this to a battery or a cell. So I take a cell here. Cell, as you know, cell has two terminals. One is positive, another one is negative. But while drawing the diagram, we don't draw a cell. We draw symbol of cell, symbolic representation of the cell. It can be represented using one longer line and using one smaller line. Here, longer line indicates positive end and smaller line shows negative end. Positive as well as negative. So using this cell, I make electricity to flow through the solution. So I take here two electrodes. One side of the cell is connected to this one electrode, another side of the cell is connected to another electrode. Here, this positive side of the positive terminal of the cell, which is connected to this electrode, it is called as anode. And the minus, which is connected to one more electrode, that is called as cathode. So cathode and anode are the electrodes. Here, chemical effect of electric current, we make electricity to flow through some conducting solution. So chemical changes takes place. Here, plus and minus should be connected to two electrodes. One is anode, another one is cathode. So we can see a gas bubble near the electrode. During the chemical changes, gas bubbles may be formed on electrode, near the electrode, and second change, there may be change in the color of the solution. The solution which we are taking here, any conducting solution you can take. The solution which you are taking here, sometimes the color of the solution changes. That is also one of the effect of this chemical effect of electric current. One of the change takes place during the chemical effect of electric current. And also there may be metal gets deposited. Metal gets deposited on the electrode. Metal gets deposited. Metal layer forms on the electrode. So these are the changes takes place during the chemical effect of electricity. But here thing is, the changes takes place mainly depends on which solution we are taking and what type of electrodes we are using. The changes which takes place during chemical effect of electric current mainly depends on the type of the solution which we are taking. There are different solutions, conducting solution through which electricity flows. So which type of solution we are taking and what type of electrodes we are using here. Based on that, these changes takes place. That is called chemical effect of electric current. So what is chemical effect of electric current? When electricity flows through any conducting solution in the sense when the electricity flows through the conducting solution, chemical changes takes place. This is called as chemical effect of electric current. So what chemical change you can see there? There may be gas bubbles near the electrode, or there may be change in the color of the solution, or there may be a metal gets deposited on the electrode. So one of the change we can see during the chemical reaction or chemical effect of electric current. As you have seen, the handlebar of a new bicycle is shiny, but after some time that shiny layer comes off. And also you can see some of the ornaments which we use. Actually, they are not the gold ornaments or they are not the silver ornaments. On some cheaper metal, this coating of gold or silver is given. So, which process we are using here? Using what process? We are depositing a layer of one metal over another metal. If you take 1 gram gold ornaments, they look like gold ornaments, but actually they are not the gold ornaments, but they are very attractive. So we can use daily different varieties of ornaments. Actually they are not gold ornaments. Gold is very costly. So to get the desired property of the gold, what we do here, we make a coating of gold over another metal. Some cheaper metal we are taking, and the desired metal which we want, we deposit over another metal. So this process can be done. This process can be done using the chemical effect of electric current. Using chemical effect of electric current, we make the deposition or a metal which can be deposited over another metal. So using the process of, using the effect of chemical effect of electric current. So how this can be done? We can understand this by taking one particular example. Take copper sulfate solution in a beaker. Take a beaker and take some which solution? Copper sulfate solution. Copper sulfate solution. Copper sulfate solution, and add some drops of dilute sulfuric acid to this. Dilute sulfuric acid. Take some copper sulfate solution in the beaker and add few drops of dilute sulfuric acid. Why? Copper sulfate solution is a conductor of electricity through which electricity flows, because it is a salt solution. Salt which we are using at home. It is not the salt which we are using at home. It is used in the laboratory. Copper sulfate solution take in the beaker, which is a conductor of electricity, but to increase its conductivity, to allow more electricity to flow through this, we have to add some drops of sulfuric acid to this copper sulfate solution. Few drops of sulfuric acid is added to this solution. Now, take 2 metal plates of copper plates or copper plates, dip 2 copper plates in the solution. Copper plates dip in the solution. This is also a copper plate. This is also a copper plate. Now, connect these copper plates. These copper plates should be connected to the battery. Connected to a battery. Like this. This way you have to connect this to a battery. Now, this is the plus, positive, as I said, longer line, positive terminal of the battery, smaller line, minus, negative terminal of the battery. So, this side is anode and this side is cathode here. In your textbook, ulta connection is given like this. In your textbook it is connected like this. So minus is connected to this side, plus is connected to this side. So this should be cathode. This is cathode and this side should be anode. Two electrodes. They are called electrodes, cathode and anode. The terminal to which minus of the cell is connected, which is called the cathode. The terminal to which plus of the cell is connected, that is called the anode. So this side is cathode, this side is anode. Take some conducting solution in the beaker, make it acidified by adding some dilute sulfuric acid solution so that we can increase the conductivity of the solution. Now, when you allow electricity to flow through the solution, when electricity is passed through the solution, what happens? Here we have taken copper sulfate. So, this copper sulfate dissociates as copper sulfate. It dissociates in the sense it splits as copper plus sulfate. Copper ion and sulfate ion. It dissociates as copper and sulfate. So these free copper, the free copper, it transferred, it passed towards cathode and it gets deposited over here. Copper gets deposited over the cathode. At the same time, here also we have taken copper plate. At the same time, when you pass the electricity, copper from this terminal, copper from this plate gets transferred into the solution and gets dissolved and restored in the solution. So understand this, when you pass the electricity to the solution, copper sulfate we have taken here. This copper sulfate, it dissociates in the sense it splits as copper and sulfate ions. These copper transferred, it gets transferred near the cathode, the terminal which is connected to the negative of the battery or the cell, that is cathode. It transferred to the cathode and gets deposited over there. But at the same time, copper from other terminal, that is the other electrode, it passed to the solution, it gets dissolved in the solution and restored. So what happens? From here, copper gets deposited here. From this electrode, copper transferred to the solution. What does it mean? It means copper gets transferred from one terminal, one electrode to the other electrode. From this electrode, copper gets transferred to this electrode. So copper gets deposited over here. We can make copper to deposit over another plate, So in the same way, here we have taken copper. Any other desired metal can be deposited over another metal. If you want to deposit gold over silver, then what you have to do? Here you have to take silver. This side you have to take gold. So this gold gets deposited over silver. So we can get the desired metal, the desired property of the metal. Directly gold, it is very costly to purchase. To get the desired property of that gold, we can give the coating of gold. In the same way, some cheaper metals we are selecting and we give the coating of some other metals, the desired metal which we want, we give the coating. We make those metals to deposit over another cheaper metal. So this process we call as electroplating. So how we can define this electroplating? Electroplating is a process. It is a process of deposition. It is a process of deposition of one metal over another metal. One metal in the sense required metal. Which metal we need? That metal we are depositing. The process of deposition of one metal over another metal. electroplating. Electroplating is the process of deposition of one metal over another metal by means of electricity is called as electroplating. So I discuss once again, I explain this once again. Example I have taken one deposition of copper metal. Here you have to take a beaker and you have to collect some copper sulfate solution. You have to take copper sulfate solution in the beaker. You have to make this solution more conducting by adding few drops of dilute sulfuric acid. Now take two copper plates and connect these copper plates to the two terminals of the cell. One is plus, another one is minus. So here one copper plate acts as a cathode, another copper plate acts as an anode. When electricity flows through the solution, what happens? Copper sulfate dissociates as copper and sulfate. So from here this copper gets transferred. It gets transferred. Copper gets transferred to the electrode. Which electrode? To the cathode, and it gets deposited over cathode. At the same time, copper from the anode gets dissolved in the solution and restored. So process continues. Once again copper from here deposited over here. From here copper gets dissolved here in the solution. So what does it mean? Copper from one metal plate, from one electrode transferred to the other electrode. So in which electrode you can deposit the metal? The terminal which is connected to minus, that is cathode. On the cathode we can deposit required metal. The metal which we want to electroplate, that can be done, that can be taken as cathode. The metal which you are taking on the cathode, upon that you can deposit required metal. This you have to remember. Related to this, one question is given in your exercise. The metal which you want to, the metal where, in which electrode metal gets deposited, the electrode which is taken as cathode. Cathode in the sense which is connected to minus of the cell. So over that metal gets deposited. So from anode metal is, it means from anode metal gets transferred to the cathode. Not directly by passing electricity, that has to dissolve in the solution, and from there it gets deposited on the cathode. This process we call as electroplating. So it can be defined: the process of depositing a metal, a required metal, one metal over another metal by passing electric current by means of electricity, we call as electroplating. Using this process, it is one of the very important in the field of industry. So this is used in the field of industry. This is one of the important applications of chemical effect of electricity in the field of industry. So this can be used to coat or for electroplate a required metal over another metal, which is used in various fields in the field of industry, which can be done. It is one of the very important effect, one of the very important applications of chemical effect of electric current, which is used in the field of industry. So as I discussed about electroplating, it is one of the most important applications of chemical effect of electric current. So coating of one metal over another metal. Some cheaper metal we are taking and we are giving the coating of some costly metals or some precious metals, so that we can get the properties of those metals which we require. So this electroplating has many applications. It is used in our day-to-day life. So how it is applied in the field of industry? You have seen chromium plating. Chromium plating is mainly done. Chromium plating is mainly done. Or chromium is deposited mainly on car parts. Car parts, your kitchen gas burner burner, as well as your bicycle handlebars, bicycle handlebars, handlebars, etc. So why this chromium plating is done, or why chromium gets deposited over another metal, as well as your bath taps, bath taps. Chromium plating is done. So why? Because chromium has some of the important characteristics. There are some advantages. So what are the advantages of this chromium? One thing, chromium is not corroded. It does not get corroded. It does not corroded. Corroded in the sense rust. It won't get rusted. It won't corrode. It is resistant to scratches. It is resistant to scratches. It is resistant to scratches, as well as this metal is shiny. It is shiny. Therefore, chromium plating is done over some cheap metals. But why we can't make these items from chromium itself? So as I said, these are the advantages of chromium. So chromium plating is done over some of the objects like bath taps or kitchen gas burners or some car parts, bicycle handlebars. Why? Directly we can make them using chromium. Chromium has these advantages. But when you take chromium itself, chromium is very costly. Chromium is expensive. Chromium is expensive. It is costly. So, directly we can make. Whole object cannot be made from chromium. Chromium is costly or it is more expensive. So, it is not economical to make whole object using chromium itself. Therefore, what can be done? We can make those object using some cheap metals, and a coating of chromium is given. So, we can get the desired qualities of chromium. Desired qualities of chromium can be obtained. What are the desired qualities of chromium? Chromium does not get corroded very easily, won't get rusted very easily. Chromium is resistant to scratches, as well as it is a shiny metal. It gives a shiny appearance. So for these reasons, we give the coating of chromium over some cheaper metals, and we use these objects in our day-to-day life. In our day-to-day life, we use these objects. Also, I have given the ornaments of, given the example of ornaments, jewelry makers. What they do? They take some of the cheaper metals and they give the coating of silver or gold over these cheaper metal, so that they get the appearance. They look like gold ornaments or they look like silver ornaments. If you take the example of 1 gram gold ornaments, actually they are not made by gold. Coating of gold is given over there. So they look very shiny, they are more attractive. So we can use them in our daily life. We can use them. We get the all properties of gold or all properties of silver over by using those ornaments. So jewelry makers usually they give the coating of silver as well as gold over some cheaper metal. So this is also done using electroplating process. And also food items, usually they are used in the cans. In the cans which are used to store food. Which is used to store food. Which is done by electroplating in over iron. By electroplating what happens, as you know, when iron comes in contact of moisture or in contact of water, reaction takes place. One thing, it gets corroded or it rusted. So reaction takes place. About the reaction of iron with the water, about that you will study in your higher class in detail. So when they react with each other, some gases are produced, poisonous gases, which spoils the food. So to avoid that, a coating of tin is electroplated over iron. So we use tin cans to store food items. To store the food, we use tin cans, which is done by electroplating tin over iron. And also the bridges as well as automobiles, they are constructed, they are made using iron. But as I said, one of the very important disadvantage or the limitation of iron gets corroded or it gets rusted very easily. Therefore, what is done here? This iron is coated with the zinc. Iron is electroplated with the zinc to avoid the rusting as well as corrosion. The automobiles as well as the bridges, they are made by iron. Iron has more strength. But directly we cannot use iron. If we use only iron, what happens? It gets rusted, it gets corroded and as well as gets rusted. So what happens? What we do here, we give the electroplate iron with the zinc to avoid rusting as well as corrosion. So the durability can be increased. So these are the applications of electroplating. Electroplating is done using the chemical effect of electricity. So we can say this is the application of chemical effect of electricity which we use in our daily life. Once again I discussed this chromium plating is done for bicycle handlebars, it is done for the bath taps as well as for the car parts and kitchen gas burners, etc. You might have seen kitchen gas burners, that shiny surface, that is the chromium plating. The main advantage of this chromium metal, advantages of the chromium metal, it has a shiny surface, chromium, it is corrosion resistant, it is not gets corroded very easily and it is resistant to scratches. But chromium is very costly, it is expensive. Therefore, the whole object it cannot be made by chromium. Therefore, these objects are made by some cheaper metals and the coating and this chromium is deposited over that metal. And also ornaments, gold and silver ornaments which we use in our daily life. Silver, gold, it is very costly. Therefore, some cheaper metals, jewelry makers, what they do usually, they select some cheaper metals and they give the coating of silver and gold which can be used as a daily, which can be used as a ornaments, which looks like, which gives the appearance of silver and gold ornaments. And also tin cans which is used to store food, they are mainly prepared or they are made by depositing tin over iron, because tin, if you directly made these from iron react and it gets corroded, it gets rusted very easily. So food which we store in that gets spoiled. Therefore, tin is deposited on iron to avoid this. And bridges as well as automobiles, they are usually made by iron because iron is it has more strength to increase the strength. But iron gets rusted, iron gets corroded very easily. Therefore, zinc is deposited. Electroplating of zinc is done over iron to avoid the corrosion of iron articles, to avoid the corrosion of these bridges as well as automobiles. So these are the applications of electroplating which is done mainly using chemical effect of electric current by passing electricity through some conductor So that is the applications of chemical